Welcome back to the deep dive. Today we're looking at a really fascinating piece of specialized hardware.
We are. It's the NTI ST-C5KVMRS-1000S.
It's a bit of a mouthful, but it's a high-res VGA and PS2 KVM extender.
Hmm.
And our mission today is really to unpack why this thing still matters. I mean, we're talking about VGA, about PS2, which sounds like ancient tech.
It does.
But it's absolutely critical in certain fields, and we want to understand how it pushes standard cables to, well, to their absolute limits.
And for anyone listening who's maybe not familiar, KVM is just keyboard, video, and mouse.
Right.
And an extender lets you control a computer from really, really far away. But the genuinely surprising part here,
The distance.
the distance,
Yeah.
1,000 feet, that's over 300 meters, using just your standard everyday CT5 network cable. Nothing fancy.
Which seems technically impossible for an analog signal like VGA. That kind of distance should just destroy the quality.
It should.
So the system has this two-part design, right? A local unit at the PC and then a remote unit where the user is.
Exactly. And that's how it manages to maintain some really impressive performance specs, even with that separation.
Okay, so what kind of performance are we talking about?
Well, for one, it's built like a tank. It's a rugged steel case. But it can push a resolution of up to 2048 by 1936.
That's pretty high res for this kind of setup.
It's very high res. And that ruggedness is key when your computer's tucked away in a secure server farm somewhere.
So let's get to the core of it. How do they actually prevent the video from turning into a blurry, colorful mess over 1,000 feet of copper?
That's where the real magic is. The biggest problem with sending analog video that far is something called color skew.
Color skew, okay.
Yeah, the red, green, and blue color channels, they don't travel at the exact same speed down the wire. Over a long distance, they get out of sync.
And the image just falls apart.
The image falls apart. So this device has an automatic adjustment feature that literally resyncs the arrival time for each color.
So it's a timing thing. We're talking about incredible precision.
Absolute precision. The system can adjust the signal delay by up to 62 nanoseconds.
Wow.
And it does that in tiny 2-nanosecond steps. It fine-tunes itself to your specific cable, your specific length, and then it remembers those settings.
Which explains the trade-offs I saw in the specs. You can't have everything at once.
No, the laws of physics still
Right. So if you want that full 1,000-foot run, you're limited to 1920 by 1200 resolution.
Correct.
But if you need that maximum 2048 by 1.36 resolution, you have to, pull it back to 600 feet?
You have to pull it back. It's that classic engineering balancing act.
So why even bother with VGA and PS2? Why not just use something more modern?
It really comes down to necessity. In fields like, say, air traffic control or secure military settings, PS2 is actually more reliable than USB.
How so?
It uses dedicated hardware interrupts. It's just a more robust connection. And in high-security environments, that's what you want.
It sounds like it's built for these very specific, centralized computing environments.
Absolutely. And the support is broad. It runs on everything from modern Windows Server down to, legacy systems like Solaris or older macOS versions.
And I saw it has things like DDC2B support, and it's TAA compliant.
Yeah, the DDC2D is what lets the monitor and computer talk to each other to figure out capabilities, and TAA compliance is a must for any kind of U.S. government procurement.
So when you put it all together, the key takeaway here is that this is an incredibly elegant solution for a tough problem.
It is.
It's taking a fragile analog signal, making it stable enough to cross huge distances on cheap copper, and keeping everything secure and reliable.
Exactly. And it says so much about what's still needed for robust infrastructure. It makes you think,
What's that?
Well, just consider for a moment the sheer amount of engineering it takes to send a PS2 keyboard signal and a VGA video feed 1,000 feet. Now, how much more complex does that problem become when you try to send a modern high-bandwidth signal like 4K at 60 Hertz over that exact same piece of inexpensive copper wire?
That's a great question. It really puts the challenge into perspective.
It really does. It gives you a whole new appreciation for every single foot of that cable run.